everybody. This is Chris Woodfield again with the program committee. First off, once again, remember to fill out your surveys. Again, this is a new format and we're really interested in getting your feedback on that. So that would help us very much to improve this format and bring you the better NANOGs and better content in the future. Secondly, we're running a poll for tomorrow's BOF. We'd like to see what topics should come up in a BOF. So if you should see a poll coming up on your screen. So if you see that poll, and feel free to vote on the topics that interest you, and we will take that feedback and roll that into the BOF tomorrow. So thank you for that. I'm introducing Timothy Winters. Tim is the CTO of QA Cafe, which tests consumer broadband equipment for IPv6 features and compliance. And he'll be presenting a talk on testing IPv6 transition mechanisms in order to support IPv6 only networks. So with that, Tim, you have the mic. Thank you.
Thanks so much, Chris. So today, as Chris mentioned, we're going to be talking about testing IPv6 transition mechanisms. In particular, we're going to talk a little bit about IPv6 only networks. I thought I'd start off with a little bit of background about myself. I've been testing IPv6 since the early 2000s. When I first started, I honestly never thought it would leave an academic lab. I started at the University of New Hampshire Interop Lab and started testing it there. I've worked as US government test lab and IPv6 ready test lab, mostly focusing at first just on compliance, but now as V6 has been deployed, I mean, I'm using it right now to talk to all of you. So IPv6 is now out in the world and we're facing more challenges, new challenges. Currently, I'm the CTO at QA Cafe, so some of the information I'm going to talk about today is through their testing. They have a tool called CD Router that focuses on testing home gateways. They also have a product for CloudShark that's for viewing captures. And all of this is part of the experience that we've gained when testing IPv6 that we can use. And we're going to talk about a little bit today, some of the lessons we've learned. I've also authored several IETF IPv6 profiles, those kind of things, just to give you an idea of some of the experience I've had to work with IPv6. So the first question that often comes up when we talk about this is, what is an IPv6 only network? People have a lot of different definitions. For this conversation, what I'm really talking about here is IPv6 only. IPv6 only means no IPv4 provisioned on the network. So, there's no DHCP to assign v4 addresses. There's no v4 gateways. For the network engineers who are really concerned, they might filter out the v4 broadcast. And this is really to lower the noise. So devices aren't looking for IPv4. They really just want only focus on v6. Network filtering is not in all networks. This is really for people who are on top of it, are worried about bandwidth constraints or bandwidth usage. One thing I want to note, some people, IPv6 only, they wonder if it means that v4 has been removed from all the products. Not in this case. Really what we're aiming for when we say v6 only is it's just not turned on, it's not provisioned to the device. Removing it from the devices is a much more complex item and not really included in this conversation. Why? So we've talked about why would we go to IPv6 only? A couple of things. One, v4 addresses have run out. There's not a whole lot more blocks you can get. As more devices connect to the internet, v6, the real thing here is running out of addresses plus the number of devices has made v6 much more important or vital to networks. One option you do have if you want to continue your v4 is to put in carrier grade NATs. They mean more functionality, more network functions in your network. It just makes it more complex. So it's not a great solution. It works in a pinch, but there's some drawbacks there. Another reason to go to v6 only is if you have two IP protocols, it means you have to secure, maintain, and upkeep two different topologies. You're having to track all your v4 stuff. They may have different topologies or go in different directions. Often people will say they get a failure they don't realize they have a v6 or v4 failure when one of them is working fine, the other side isn't. So these are all issues with why you might want to consider moving at least parts of your network to IPv6 only, because then you only have to worry about one of the two IP protocols. On that, recently the US government OMB office announced that they're trying to move federal networks to 80% of them by 2025 to IPv6 only. I think this is a really interesting. I think they're ahead of the game, but I think they're doing the right things and understanding that helps them secure their networks, because going to v6 only just makes things easier. It's more focused. They're not fighting on two different fronts. So all of this is why you might want to move to an IPv6 only environment. Oops, went the wrong direction. Transition mechanisms. So often what we find, transition mechanisms, what we're going to talk about today is focused on ones that work or support v6 transitioning over v4. So the reason you'd want to do this is not every device in your network at the edge in particular will be able to support v6 out of the box. They have a lot of different things that might cause that. In this case, what we're really talking about are the 5 I've listed here. I'm going to talk a little bit about some of the testing needs of these guys. So we're going to talk about dual stack light, MAP-T, MAP-E. A very popular one in the mobile space, or the next two, is DNS6.4 and NAT6.4. Many of you, if you have your phone, for example, T-Mobile network is v6 only. You're using v6 right now on your phone. It works fine. All of those are transition mechanisms to allow a v6 only device like your cell phone to talk to a v4 service. All of these are transition mechanisms. What to note is these all have different, and what we're going to talk about is some of the lessons we've learned from testing these and what you need to look for as a service provider, but also as a manufacturer on the network, as someone who's building a product on the network. So common testing roadblocks that we found that are cause issues that people want to verify work. We're going to talk about fragmentation. That's a constant issue with this, and some of this has to do with the way transition mechanisms work, and I'll talk about that. Configuration complexity. What you want to do here is test that you can change, or what kind of options you have for configuration of those many transition mechanisms. One of the bad things about transition mechanisms is there's lots of them. As you saw from that list, there were 6 different ones listed. There's lots of options, so it's not as easy, it's not as cut and dry why you would choose one over the other, which leads to configuration. And the last part is protocol complexity that we'll talk about a little bit today. IPv4 and IPv6 have different fragmentation rules. So we're going to talk a little bit about fragmentation issues. So the first thing is, because they're different protocols and have different fragmentation, IPv4 allows, in many cases, allows fragmentation in the network. IPv6 only allows fragmentation at end-to-end. So because of some of this, there's fragmentation, you have to take some things into account. One of them on a high level is you want to make sure that security devices, fragmentation is often when they see fragmented packets, many firewalls will shoot them down or stop the connection from happening. And the reason they do this is because it's complex. Sometimes it's difficult to get all the fragments. So for a security firewall, something doing IDS or IPS, it needs to see the entire connection. So it has to wait to get all the fragments. And a lot of firewalls don't have time for that, don't want to have the resource constraints of having to buffer all of those packets. So they'll drop them, and that's bad, and you have to deal with that situation. Also, many of the transition mechanisms use encapsulation. So when you're using something like encapsulation, it inherently shrinks the MTU, which I'll talk a little bit more about later. But what that means, and I have a diagram next that'll show that, it causes issues with the packets getting smaller and smaller at the edges, which leads to more fragmentation. Additionally, there are technologies like UDP that don't inherently support fragmentation. So you have to make sure that you support it on the IP layer. TCP does a lot of this for you through some of its algorithms, but UDP, you have to be, you rely a little bit more on the IP layer to be able to do this. So this is a common topology. In this case, I just said dual stack light. A lot of the technologies are very, very similar. So what'll happen here is, there's a device on either end. So in this case, the AFTR would be in the ISP network, and the CPE would be the device on the end, and the home user is trying to get an IPv4 flow end to end, and they're running over an IPv6 only network in the middle. So, in this case, for this fragmentation example, I wanted to demonstrate the packet size on either end of v4 is 1460. The reason you can't use the full 1400 is because in the middle, there's an IPv6 layer that's encapsulating it. And that's eating away at the bandwidth, and you have to make sure you support that. One of the things dual stack light requires is it requires fragmentation at the IPv6 layer, not the IPv4 layer. So there's a couple of test cases. You have to make sure that your device properly is dealing with those and fragmenting at the correct layer. If it does it at the v4 layer, it causes issues and confusion. And these are common failures we've seen when we run these test cases with the CPE devices. So those are things to look out for and make sure that you're testing. Configuration complexity. This one is network components. There's a couple things here. One of them is many times we've had people come to us saying, an ISP say, hey, we have these two different devices and they're failing and we think there's something wrong with it. We can't figure it out. And in the end, it turns out, it has to do with, there's multiple methods to configure the CPE, the home gateway, and the ISP needs to make sure that they're using the same variables everywhere to make sure that the device is properly getting the right information. Obviously, many of the transition mechanisms, you need to make sure that when transitioning, everything is working correctly. You got to make sure the addressing is set up correctly, the routing, all of this to make this work. And it's extra configuration that you normally wouldn't have to deal. If you had an IPv6 only network, you could just have to worry about the addressing and protocols. This adds, a second, there are parts of your network. The reason you do this is so that you don't have to do this everywhere. You're only doing this in the core, but it's still, you have to keep some state and make sure you keep track of configuration. A common example, back to the fragmentation, one thing we always want to check is the MTU configuration. You want to try to avoid that fragmentation issue I talked about earlier. So you want to make sure you configure your network properly to deal with these encapsulation protocols, that you set your MTUs correctly so that you avoid fragmentation issues whenever possible. One thing we often test for is we want to ensure that CPEs come up properly after a power outage or reboot. Often what happens is sometimes the CPE will come up and it'll default to its default configuration and lose its transition mechanism. You also, again, this goes to the configuration issue I talked about earlier with syncing them up. You want to make sure that whatever management protocol you're using, TR69, DHCP, USP, SNMP, whatever it might be, your SDN solution in today's world, NetComp, all of those things, you want to make sure that you properly have all that information set up. Also that your device, when it gets that information, does the correct things, right? So you want to test the protocol, but you also want to make sure that when you set up transition things that your CPEs do the right thing. That they absolutely follow the configuration. Address complexity. Several of these translation, in particular translation ones, they take the 100, the joy of IPv6 is it has 128 bits. And because of that, sometimes people put some semantics address techniques, stateless, so they change the address a little bit. And this makes it difficult in testing for a tester because often they need extra tools to figure out what the addresses were. Also, when testing this stuff, it becomes very difficult to test across a network. This is where isolated testing should be, don't just set it up on your network and run the testing because it can be very hard to track an issue across a network because the addresses are changing and that makes all the tools difficult. So these are the kind of things that you want to make sure that you're doing in-house lab testing beforehand before you actually deploy it to a network. Obviously, protocol complexity. I've talked about all of these things. You want to make sure you're monitoring them with any extra protocols. You have to make sure you understand, the downside to transition mechanisms is you do need to understand both the v4 and v6 components of this. So all of these things are areas that, we run into a lot of corner cases with these protocols, and we want to make sure that you cover all of them. And in particular, you want to do it in an automated fashion because manually testing can be very difficult. Because there's so many little tiny corner cases for these types of things. Here's my contact information, and I was hoping I think we have a little bit of time for questions, Chris.
Yes. Let's see. If you have questions, feel free to submit those to the in the web interface. Let me look to see what we have currently. Currently, only have one question. And that question is, what do you look for as the minimum acceptable standard for vendor equipment to be considered IPv6 ready?
This is a great question. So there are several programs in the world you can use for this question. One of them is the IPv6 Forum has a global program called the IPv6 Ready program. That is a marketing program that allows devices to test the core IPv6 RFCs. They cover all the must and shoulds in those RFCs. And it kind of covers your base stack. And really what that does is that makes sure when you put the device on a network that it'll work. Luckily for us, just recently, as of 2 days ago, they updated that logo to focus on IPv6 only and IPv6 on by default. So now devices who apply for that ready logo are tested in an IPv6 only environment, which, as I talked about today, is becoming more and more critical. And then on the IPv6 enabled by default, we want it to be much more plug and play. We want you to be able to take a device, plug it in and go. So that is a program. If you're looking for a piece of equipment, I strongly suggest you go to IPv6ready.org. They have thousands of devices at this point listed that have participated in that. The US government has I talked about the OMB mandate. They have a US Gov device list that lists all of the devices. And that kind of goes in a much wider scope. It includes things like routing protocols, security, those types of things that people might be interested in. Those are two great lists to start with for looking for what vendors have done, what testing they have had independently verified in all of those cases. That's the upside to both of those programs is they independently verify that information.
Thank you. We have one more question in the queue. Two more. Okay, first one. Why would I do AFT and or other tunneling mechanisms instead of just doing dual stack and possibly CGN if I have an IPv4 address space shortage?
So, right, this is a common question. So one of the things I talked about earlier is if you're doing dual stack everywhere, that, I think some people envisioned a world, 5 or 10 years ago where we would have dual stack for quite some time. What's starting to happen is it means you have to protect your network and monitor 2 different IP addresses all the time, right? Because if some services support v6, some support v4, you have to monitor to make sure the end user can get to both of those. So if you want to run dual stack, you can, but it's just more difficult. What we've been finding recently is a lot of people have had success. It started kind of in the data centers where they were greenfield and they were able to go v6 only, but it's really starting to show up in places in mobile and other networks. Obviously, enterprises have been slower to deploy this, but what we've seen is the value of IPv6 only is then you can focus not having to worry about dealing with 2 fronts at the same time. You're really just doing that. For CGNs, the real deal is they can exist in the network. It's an extra function, and you have to make sure that all of the things are properly synced. It's really tough with logging and some other things to be able to properly track what's going on in the network. They can work, and I think they work in a pinch, but I think it adds extra networks complexity, and all we hear about today is people wanting to avoid network complexity as much as possible.
Thank you. I apologize on the behalf of my landscapers.
No, that's fine. You barely hear them.
Okay. All right. Okay. Next question. Are there certain applications that you've seen that typically have more issues on a v6 only network?
So areas where we've run into problems, it's kind of funny. There's some places where we've seen issues with applications on odd stuff like installing or updating. So the cloud service that does the install is v4 only. And if you're on a v6 only network, all of a sudden you can't update your software. So that's an interesting one. We've seen a couple of issues there. In generic applications, I'm not sure one place works. Obviously, cloud services, you want to make sure that the cloud service supports it and everything underneath that. I mentioned the installers and updates are other places. For areas of applications, we've seen it all over. We've seen a lot of success in a lot of places. Apple helped a lot with this when they moved their app store to v6 only. Sorry, Chris. And I think that's where we're at. Yeah, if you have any more questions, Chris, please feel free to fire away.
Okay, there's one more question.
Okay.
I'll hit mute immediately afterwards. The questioner wanted to discuss 100% IPv6 deployment for an ISP for businesses and subscribers. Are you forced to use a 6-to-4 DNS for subscribers in order to be 100% compatible with the internet?
No, you could do. I mean, to be completely honest, right? Not everything on the internet is v6 only available today, right? There's still plenty of services that do v4, and that's where something like a DNS 6.4 comes into play and can help the network. In a perfect world, we would love for everything to be accessible on v6, but that's not going to work. So I think realistically, where we are right now, if you tried to have an ISP that was doing v6 only, it's going to need some sort of transition mechanism at the edge, whether it's a NAT6.4 or a DNS6.4. I think that's kind of, some combination of those today to get you where you want to go. The good news is we've had a lot of success using those transition mechanisms. There's lots of deployments that have done that. So I think that's really good.
All right, one more question.
Yeah.
If I'm on an end user network and I already have sufficient IPv4 space, is there any benefit to going IPv6 only?
So if you're on an end network and you have plenty of v4 addresses, maybe not. The only thing is, I think in the future, what might happen is there's two things. There's been a couple of interesting studies. Facebook put out a study where they found that v6 only connections were faster. And the reason for that is because they didn't have the NAT translator. So, I'm not sure that's true on every network, but I do think there's some benefits to doing that. I also think in the future, I think, today probably not a huge benefit to doing it, but the real thing is you don't want to get caught at the point where in the future somebody props up a v6 only service that your users want to get to and can't. And then your users are using a transition mechanism and they're getting a worse experience. So, moving to v6 only, maybe you don't need to right now, but you definitely want to make sure you're A, deploying v6, and then B, for v6 only, it's really, the benefit of getting rid of all the holes that you had to plug when you were deploying your IPv4 deployment.
All right, thank you. I don't think we have any more questions in the queue. Thank you very much for your time. Again, please, the expo is still ongoing if you wish to join. So follow the link on our site to that to have for vendor presentations. Don't forget the surveys, and this concludes today's content. So thank you all very much, and we will see you again tomorrow.
Thanks so much, guys.
This is Chris signing off for NANOG for the day. Thank you.